Alrighty, here we go. We are moving on now because graphing isn't always the best option. All right. You saw that when we did the wartime battle worksheet is sometimes you do not get these two linear equations to intersect at a point that gives you exactly integer results. And so for that reason, we have to have some other options and some other tools in our tool belt so that we can figure out how are we going to solve this system. So hence that leads us right into today. Chapter 6, Section 2, Solving Systems by Substitution. So make sure that you have your note sheet in front of you. And I want you to get used to looking at this method. And again, I can't stress enough, you have got to show your work. You've got to go step by step because there's so many little places where an error might occur that we need to see what you've done so that if there's a mistake, we can go back and find it. Otherwise, you got to start over from scratch all the time. And frankly, there's nothing more frustrating than that. Ugh. So here we go. Here's a system. We have y equals 3x, y equals -2. So we could graph this, absolutely. But what I want to do is give you another option and to do it algebraically. So here's what we're after today. You have two equations. I'm telling you that y equals 3x. So what I want you to do is put a box around that 3x, okay? Because here's what we're going to do. We're going to take what y equals and we're going to substitute for y in the second equation, which means since y equals 3x and I've got y in this equation down here, I'm going to put it on the left-hand side, 3x. On this side, I'm going to have x minus 2. And now we've taken this system of equations and we use substitution to get it in one variable. We can solve for x now. Go ahead and get your variables on one side. Okay, subtract 1x, subtract 1x. This is where I like to really get into this. Come on, fling that guy over here. All right, because these go away and it's kind of like it appeared over here as a -1x. Well, hot diggity dog. All right. You at this point should now be able to tell me x has to equal -1. Boom. Not done. We have to figure out what y represents or what y is equal to. But now we know what x equals. So now we could come over here and say, well, y has to equal 3 times -1, which means y has to equal -3. We should also go back and check and make sure that this particular ordered pair, -1, -3, because that's your solution now, that works in this other equation. Plug in a -1 for x. So let's come down here to check and say, does -3, this y value, does that really equal -1 minus 2? You say, oh, yep, that works. So there's your answer. Okay, boom. Nice. Let's try another one. Okay, here's my system. I have y equals x plus 1 and 4x plus y equals 6. Because this equation, which happens to be written in slope-intercept form, is already set up for me that y equals this blob, this algebraic expression. What you're going to do is take this box or this blob and substitute it in for y in the other equation. Nice. So now instead of 4x plus y equals 6, I'm going to say 4x plus all of this, x plus 1 equals 6. The reason that I do that is now I only have one variable, and now you can calculate the value of x. Combine like terms. Subtract 1. Oh, for goodness sakes. These numbers are being so nice to you. Look at that. 5x equals 5. Therefore, divide x equals 1. Okay, that's only halfway. Okay, now we've got to go back and plug this in. You can plug it in either equation. Regardless of which one you choose, you should get the same value for y. If you don't, boop, 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 that means something went wrong and you better fix it. Okay, if you want to use this equation, you'd say y equals 1 plus 1, which means y equals 2. I would check it in this one as well just to make sure. plug a 1 in for x. 4 times 1 plus y equals 6. Well, that's 4. If I subtract 4 from each side, then y equals 2. There you go. Your solution is 1, 2. Done. All right, let's keep building. Now let's take a look at this one. Okay, this one, here's my system. Both of these are written in standard form notation. Okay. Ideally, what you would like to do is solve for one of these variables so you can substitute it. And guess what? You have the choice of doing it either way. I want you to see both ways just so you see how to tackle this. Okay. Personally, if I were looking at this, and let's do two methods. We're going to say solve for x here and then work through the problem. And then we're going to come over and solve for y as well. And I'll show you both ways to prove to you that it doesn't matter which way, you'll arrive at the same answer. I think what I would do is take a look at the second equation maybe, and say x minus y equals 5. If I wanted to solve for x, I'd have to get it by itself, which means add y, or fling that minus y over to the other side. That goes away. X equals y plus 5. Okay, now I've got this equation solved for x. I can go back into this top equation and substitute this expression, because x equals all of this y plus 5, and substitute it right there. Let's go. Plug y plus 5 where this x was. Now I'm going to say plus 2y equals negative 1. Now what I've done, because of the substitution, is gotten a new equation with only one variable. Combine like terms, because on the same side of the equation I can simplify this a little bit and clean it up. And I get 3y plus 5 equals negative 1. Now go and solve for y. And you get 3y equals negative 6. So y has to be equal to negative 2. Boom. Okay, if y equals negative 2, go back up in either one of these equations and figure out what x is. So if I came up here and I said, oh, if I wanted to use this equation, I'd say x minus y, but y is negative 2. That equals 5. This is x plus 2 equals 5. Haha, x has to equal 3. Okay, so I'm saying that my solution is 3, negative 2. Okay, plug that in here and see if it works, just to be sure. 3 for x, negative 2 for y. Okay, 3 plus negative 4. It works. There you go. So here's my solution for this one. Okay, 3, negative 2. Now, sometimes we just like to kind of stick with the same format and say, oh, I like solving for y. I want to solve for y. It's easy for me, blah, blah, blah. Okay, let me show you how it would work in this situation. Solve for y. Okay, I have two equations here. And I'm going to tell you this. Since this has a 2y, I'd have to get x on this side and then divide everything by 2. And that's going to leave me with fractions. Not saying that's bad. I'm just saying it's going to be a little more work. I would rather look at this equation and solve this one for y. Okay, so let's start with x minus y equals 5. Solve this for y. Okay, now you can either subtract x from each side and then divide by negative 1, or since this is a minus 1y, you could fling that over here. If I added y to each side, then it's positive already. This disappeared, and I have y plus 5. Now you just have to subtract 5, and you get y equals x minus 5. You would get the same answer here if I had subtracted x from each side and divide everything by negative 1. Okay? All right, so now y equals, let me move this up a little bit, y equals x minus 5. right here. So now what I need to do is substitute this in the first equation up here, okay? So now I have to come up here and say, alrighty, x plus 2y, and I'm going to put parentheses here, equals -1. But instead of writing y, I'm going to put x minus 5, that algebraic expression. So I'm substituting in for y. That makes this new equation only in the one variable x. Okay, so we have to distribute here. Combine some like terms. So I get 3x minus 10 equals -1. Add 10 to each side. You get 3x equals 9. Well, hot diggity dog, x equals 3. Does that look familiar from over here? Yes. Then you would take and substitute 3 in either one of those equations and figure out what y is. If I took that second equation that said x minus y equals 5, plug 3 in here. Okay, 3 minus what number equals 5? Think about that. You should end up with -2. Algebraically, you'd subtract 3 from each side. You'd get the opposite of y, or this is like -1y equals 2. And then when you divide by -1, sorry, I know I got to get this up higher so you can see it, then you get y equals -2. Okay? Regardless of which way you approach it, there's your answer. Okay? All right. One last one, because of course we got to have some sort of word problem. Okay? So let's tackle this. The sum of two numbers is 75. Stop right there. Your algebraic mind and your algebraic eyes should take and translate this into an algebraic expression. So I have two numbers. What do you want to call them? You get to pick variables. If you like sticking with x and y, go ahead. Let's just do that since that's what we know. Sum means adding. So I have two numbers that add up to 75. That's the first sentence, okay? The first number, okay, so we should really define this. Let's let x be the first number, and that means y is the second number. And I'm using hashtag for number because back in the old days, that's what that stood for, silly. Okay, the first number, that's x, is, let's start translating that. The first number is 1 more than. 1 more than means that we're adding 1, okay, then the second number. Okay, the first number is 1 more than the second number. Find the two numbers. Well, there you go. Now, I know some of you have shortcut ways of doing this, but I want you to see it algebraically so you see how to solve it. Okay, x is the first number, and that has this relationship, y plus 1. X is y plus 1. So let's go to that first equation, and instead of writing x plus y equals 75, instead of x plus y is 75, we're going to substitute this algebraic expression. Now you have an equation in one variable, and you can figure out what the value of y is. Y plus 1 plus y is 75. That's 2 y's is 75. Subtract 1, you get 2y is 74. Oh, you don't need a calculator. Come on. Do this in your head. Divide by 2, and you get y is 37. 37. So now that you know what y is, come back up here. If y is 37, that means x must be 38. Okay, does that work? Is 38 x and 37 y, does that equal 75? Yes, it does. There you go. All right, so solving systems by substitution is what we're working on today. If you need extra paper to show your work, I want you to do that, okay? Announcement is for 7th and 8th grade students. Remember, spring fling tickets are on sale in the cafeteria. They're Sorry for the interruption. I believe that this is your homework and practice workbook. I think it's page 41. So look for this page. Like I said, if you need more work, because your workbook doesn't always give you that, get an extra piece of paper. Show your work, show your work, show your work. Your final answer is always going to be an ordered pair. You need a value for X. You need a value for Y. All right? Show your work. Be careful. Watch your signs. And may the force be with you.